The National Electrical Code, or NEC, has undergone revisions that impact the allowable copper wire sizes for electrical services. Specifically, changes have been implemented regarding 150 amp and 200 amp services. In the 2023 NEC for a 200 amp service, the minimum copper wire size is 3/0, which is 250 kcmil. This contrasts with the previous code, such as the 2017 NEC, where 2/0 copper, equivalent to 150 kcmil, was permitted for a 200 amp service. Similarly, for a 150 amp service, the current 2023 NEC mandates a minimum copper wire size of 1/0, or 100 kcmil. Under the previous 2017 NEC, 2/0 aluminum, or 150 kcmil, was allowed for a 150 amp service. The underlying reason for these changes lies in updates to ampacity tables within the NEC. These tables dictate the current carrying capacity of conductors based on their size and insulation type. The previous ampacity tables were generally based on a 75 degrees Celsius insulation rating. The updated tables in the more recent NEC editions are based on a 90 degrees Celsius insulation rating. This shift to a high temperature rating allows for higher currents to be carried by the same size conductor without exceeding the maximum temperature rating of the insulation. It is crucial to consult the specific ampacity tables within the relevant NEC edition to determine the appropriate wire size for a given application, taking into account factors such as the ambient temperature, the number of current carrying conductors in a raceway or cable, and any applicable directing factors. The NEC provides detailed guidelines and tables for calculating ampacity and making necessary adjustments. The general rule is that larger conductors have lower resistance. The National Electrical Code is a set of standards to protect people and property from electrical hazards. The NEC is updated every 3 years, and the latest version is the 2023 NEC. It is important to consult the latest version of the NEC to ensure that you are following the most up-to-date electrical safety standards. Here is some more information about ampacity. Ampacity is the current, in amperes, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacity of conductors based on these factors. Here are some general guidelines for determining the ampacity of conductors. Firstly, select the correct conductor size. The NEC provides tables that list the ampacity of conductors based on their size. Select a conductor size that has an ampacity that is equal to or greater than the load that the conductor will be carrying. Secondly, consider the type of insulation. The type of insulation on a conductor affects its ampacity. Conductors with higher temperature ratings can carry more current than conductors with lower temperature ratings. Thirdly, consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the conductor. The ampacity of a conductor decreases as the ambient temperature increases. Fourthly, consider the number of conductors in a raceway or cable. The ampacity of a conductor decreases as the number of conductors in a raceway or cable increases. This is because the conductors generate heat, which can cause the temperature of the conductors to rise. The NEC provides tables that list the directing factors that must be applied to the ampacity of conductors when there are multiple conductors in a raceway or cable. Here is some more information about conductor sizing. Conductor sizing is the process of selecting the appropriate size electrical conductor for a particular application. The correct conductor size is essential for ensuring the safe and reliable operation of electrical equipment. Firstly, determine the load. The first step in conductor sizing is to determine the load that the conductor will be carrying. The load is the amount of current that the electrical equipment will draw. Secondly, select the conductor material. The most common conductor materials are copper and aluminum. Copper is a better conductor of electricity than aluminum, but it is also more expensive. Aluminum is often used for large conductors because it is more cost-effective. Thirdly, select the insulation type. The insulation type is the material that surrounds the conductor and provides electrical insulation. The insulation type must be suitable for the application. For example, conductors that will be exposed to high temperatures must have insulation that is rated for high temperatures. Fourthly, determine the ampacity. The ampacity of a conductor is the amount of current that it can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of conductors based on their size, material, and insulation type. Fifthly, apply correction factors. The NEC requires that correction factors be applied to the ampacity of conductors in certain situations. For example, correction factors must be applied when the ambient temperature is high or when there are multiple conductors in a raceway or cable. Sixthly, select the conductor size. Once you have determined the load, conductor material, insulation type, ampacity, and correction factors, you can select the appropriate conductor size. The conductor size must be large enough to carry the load without exceeding its temperature rating. It is important to consult the NEC for specific requirements and guidelines on conductor sizing. Here is some information on the NEC tables. NEC tables are tables in the National Electrical Code that provide information on the ampacity of conductors, the size of conduits, and other electrical information. The NEC tables are used by electricians, electrical engineers, and other electrical professionals to ensure that electrical installations are safe and compliant with the NEC. There are many different NEC tables, each providing information on a specific topic. Some of the most commonly used NEC tables include, firstly, Table 310.15. This table provides information on the ampacity of conductors. Secondly, Table 310.16. This table provides information on the ampacity of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius. Thirdly, Table 310.17. This table provides information on the ampacity of single insulated conductors rated 0 through 2000 volts in free air. Fourthly, Table 310.21. This table provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. Fifthly, Table 310.15b3. This table provides adjustment factors for ambient temperature. Sixthly, Chapter 9 tables. These tables provide dimensions and percent area of conduit and tubing. The NEC tables are essential tools for electrical professionals. They provide the information necessary to ensure that electrical installations are safe and compliant with the NEC. Here are some additional considerations for electrical wiring. Firstly, understand the purpose of grounding. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Secondly, use the correct wiring methods. The NEC specifies the approved wiring methods for different applications. Use the wiring method that is appropriate for the environment and the type of equipment being installed. Thirdly, protect conductors from physical damage. Conductors should be protected from physical damage by using conduit, cable trays, or other protective measures. Fourthly, properly terminate conductors. Conductors must be properly terminated to ensure a good electrical connection. Use the correct type of connector for the conductor and the equipment being connected. Fifthly, label all circuits. All circuits should be clearly labeled so that they can be easily identified. This is important for safety and for troubleshooting purposes. Sixthly, inspect electrical installations regularly. Electrical installations should be inspected regularly to identify any potential problems. Correct any problems that are found promptly.